Okay, this is free response number 3 from the packet I graded. So this is what you were given, and for part A, you need to find g of 2, so that means wherever there's an x, you're going to replace it with 2. And so this means we're looking for the area under the curve from 1 to 2. So if you look at the picture, I'm just going to do the right side. From 1 to 2, you're going to get this triangle like that. So the area of a triangle is 1/2 base times height. So the base from right here from 1 to 2 is just 1. And the height is, if you have to kind of like look at the picture, it's a little hard to tell, but it should be 1/2, and if you wanted to prove that, you could do a distance formula if you wanted to go crazy with that. And this gives you 1/4, but keep in mind this is under the x-axis, so the answer is negative 1/4. Okay, so that's g of 2. Okay, next is going to be g of negative 2. So that means the integral from 1 to negative 2. I'm just replacing the x with negative 2. But as you are aware, we're not allowed to have the bigger number on the bottom, so you're going to switch them. And when you do that, you have to put a negative in front of the integral sign. So this is just asking for the area from negative 2 to 1. So let's make some room. Okay, so we know we're going to have a negative, and then we have to do the integral. So from negative 2 to 1, so here's the picture. And at negative 2, it starts looking like this. It's a triangle. And then we're going to have a semicircle. And then it's going to go to 1. So that's it. It's just those two things. Okay. So first let's do the triangle. So that's going to be 1/2 base times height. And to that, we're going to add half of a circle. So that's going to be pi r squared over 2. And now we just have to figure out what each of these things equal. So the base that's going from negative 2 to negative 1 is just equal to 1. And then the height is 3. Just look at the picture. Okay, plus pi, now we need to figure out r. Well, this circle is going from negative 1 to positive 1, so r is just 1. Okay, so that's going to give us 3/2 plus pi over 2. And you could leave your answer like, oh, sorry, we have a little mistake. This piece here is under the axes, so it should be negative. So there, if you wanted to remember, you could put the negative here, or however you want to remember it, just remember it. Because when you do pi r squared, no matter what value you put in, even if you put in a negative number for r, since it's squared, it's going to be positive. Okay, so this is your answer. If you wanted, you could distribute. It doesn't really matter. You'll still get the same points. Okay, let's go to part B. Okay, so we need g prime of negative 3, and if it doesn't exist, then we have to say that. Okay, so we know that g of x equals this. So if I want g prime, I'm going to take the derivative of each side. So this is the second fundamental theorem of calculus, so that means that this just becomes that. So we're looking for g prime of negative 3. So we're looking for f of negative 3. So the picture that they gave you is of f, so just look for when x is negative 3, what is y, and the answer is 2. Okay, and you could figure that easily because it's just a line, so you could just count up and over, and you could, if you just wanted to confirm it was 2 and you weren't confident in your abilities to just look at it. Okay, so that's that. Now, we need to find g double prime of negative 3. Okay, so if g prime is equal to f of x, then g double prime is equal to f prime of x. So if we want g prime of negative 3, we really want f prime of 3. So what does f prime means? It means the slope. So we want the slope at x equals 3. That's our goal. Okay, so when you look at the picture, when x equals 3, that's on a line. So the slope on the entire line would be the same. So let me make some room here. You could take any 2 points on a line and you'll have the same slope. So 2 points are 1, 0 and 3, negative 1. So if I do y2 minus y1 over x2 minus x1. Oh, I'm an idiot, sorry. Ignore that. I hope someone caught that I was doing the wrong thing. It's negative 3, not positive 3. Forgot my little negative here. Okay, so the slope at x equals negative 3. So the points, that's on a line still also, and also on that line is negative 4, 1, and negative 2, 3. So y2 minus y1 over x2 minus x1. And we get 1. And that's the answer for part B. Okay, let's go to part C. Okay, where is there a horizontal tangent line? Okay, so a horizontal tangent line has a slope that equals to 0. So if they want to know when does G have a horizontal tangent line, they're actually asking when is the slope equal to 0, meaning when is the derivative equal to 0. Okay, well we know that G prime is equal to f of x because we already did that previously. So if they're asking when G prime equals 0, they're really asking when is f of x equal to 0. So all you have to do is look at the picture, and you see that happens at x equals negative 1 and x equals positive 1. And then for each of those points, determine if it's a min, a max, or neither one. So, and justify your answer. So at x equals negative 1, f goes from positive to negative. Okay, so it goes from positive to negative. So that means there's a max at x equals negative 1. I'm going to make some room up here. Okay, and at x equals 1, there is no sign change. So there is neither a min nor a max. Okay, and now we're up to part D. And for part D, it's saying between negative 4 and 3, find points of inflection. So G will have a point of inflection when G double prime is equal to 0. Okay, so from the previous part, we know that G double prime is equal to f prime of x. So then the question becomes, when is f prime of x equal to 0? So a derivative will equal 0 when there's a change from increasing to decreasing or decreasing to increasing, in other words, like a critical point. And this happens at, well, this would be your explanation because it's saying explain your reasoning. So you're going to say this, that when G double prime equals 0, there is a point of inflection. Okay, that's where you'd start, number 1. Number 2 is G double prime is equal to f prime. So that means you're looking for when is f prime equal to 0, and you're going to say f prime is equal to 0 when there is a change from increasing to decreasing or decreasing to increasing. This happens at x equals -2, x equals 0, x equals 1, and that finishes number 3.